All right, let's get back into this. Arithmetic sequences is section 5. By the end of this lesson, you should be able to recognize arithmetic sequences and then relate those to linear functions. So chances are you've heard the word arithmetic or arithmetic, depending on how we're saying it, but arithmetic is adding and subtracting. It's the most basic thing we do in math. A sequence is a set of numbers. So, set of numbers is a sequence in a specific order. So they're not just random numbers, but all the numbers are related in some way. So an arithmetic sequence is a numerical pattern that increases or decreases at a constant rate called the common difference. So in all of these that we're going to do, you need to find that constant rate or the common difference. So numbers like 3, 5, 7, 9, 11, they have a pattern to them. Chances are you could guess the next number. Hopefully you said 13, or we could even go backwards. What would go right here? Hopefully you said 1. There's a pattern here that every time it changes by 2. That is our common difference. We use D for difference here. And like we said, they can either go up or down. So like this one, 33, 29, 25, 21, 17. Hopefully you can pick out the next one. Just subtract 4 more and go down to 13. The 3 dots used with sequences are called an ellipsis. The ellipsis indicates that there are more terms in the sequence that are not listed. So if you look here, dot, 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 means that we are way too lazy to write down all the numbers because it's literally going to go on forever. So we put dot, dot, dot saying that it continues. So determine whether each sequence is an arithmetic sequence and then explain. So what you're looking for is a common difference. This should look a little familiar because we just did this, saying if something was linear or not. So ask yourself, how do you go from -4 to -2? Well, I add 2. Now make sure that that's the same for every number that they give you. Once you run out, you assume that this pattern continues if there is a pattern. So because all of these go up by 2 every time, it is arithmetic. The difference is +2. So now the next one. This is a little tricky. It's not as easy to see how we go from 1/2 to 5/8. So what we really did here was we, in our head, did -2 minus a -4, and that's how we got 2. And then we did 0 minus a -2, and that's how we got 2. And then we did 2 minus 0. So I did this number times that number, to get, or minus that number to get the difference. So that's what I'm going to do here. I'm going to do 5/8 minus 1/2 and see what I get out. Now remember, in order to add or subtract fractions, you have to have a common denominator. So 1/2 is the same thing as 4/8. So this right here, I end up with 1/8. So this difference here is 1/8. Now let's do the next one, 3/4 minus 5/8. Let's see what we get out. So again, common denominators. I'm going to turn this into 6/8. So I end up with 1/8 again. Awesome. Check it for every single one. Remember, some people got that wrong on the quiz. Don't just assume. So 13/16 minus 3/4. So we'll leave this one as 16. Change this one to 16. So I get 1/16. Not the same. So this is not an arithmetic sequence. There is no common difference. So we can use the common difference to find the next term in our pattern. So back in the day, you were given things like this in like kindergarten, where it said, notice a pattern and then continue it. So the first thing you have to do is actually find the pattern. To go from 5 to 9, remember all we're doing is either adding or subtracting. So because the number is going down, I know I'm subtracting, and I'll subtract 6. Double check to make sure that works for all of them. And then to get to your next one, you just subtract 6 more. So -3 minus 6 is -9. If you want, you could keep on going literally all night. Just keep on subtracting. That's not right. And we could find the next pattern in this sequence. Now, one thing that's awesome is that we can come up with a formula for this, because sometimes I don't want to just find the next number in this. What if I want to find like the 100th number? Like this is my first number, second number, third, fourth, fifth, sixth. What if I want to skip all these and find the 100th number here? No, I'm definitely not going to write all of those out, so let's talk about a formula. We're going to create something called a recursive formula. Recursive formulas are when succeeding terms are formulated from the previous terms. So basically, if I knew the 99th term right here, if I told you the 99th term was negative 432, you should be able to tell me the next one, but you have to know this to move on to the next one. So if we look at all this, it eventually leads us to this formula. This formula you need to memorize. And this formula says that the nth term of an arithmetic sequence with first term A1, so this is first term, and common difference D is given by this formula. N has to be a positive integer. So N is the number term we want. So like if I asked you to find the 100th term, you're going to plug in 100 there. So we have this sequence. Write an equation for the nth term. So first thing, let's use our formula. So it's whatever our number is the first term plus the number we want minus 1 times the difference. So we need to plug a couple things in. We need to know the first term. That's nice and easy. It's literally the first thing they give you. We don't know what term we're finding, so we leave the n there. And the other thing we need to find is the common difference. So you go back up to your sequence and you say, how do I go from 3 to negative 10? Well, I would have to subtract 13. You can double check that that works for the next one. 10 minus 23 is also negative 13. So that's my common difference, negative 13. Find the 15th term of the sequence. So all we're going to do is plug in 15. N equals 15 here. So we get A of 15 equals 3 plus 15 minus 1. And we're going to multiply that by negative 13. And then it's just a math problem. This becomes this. Oops, negative. So then you got to do 14 times negative 13. You end up with 3 minus 182, which is negative 179. That is the 15th term. If you wanted to, you could prove this by going on and on and on and making sure that you get that. The next one is to graph the first 5 terms of the sequence. Now hopefully you're connecting that all of the stuff that we've been doing in chapter 3 is related. When I graph these things, I should end up with a straight line. My rate of change is exactly the same for all of these. It's 13. So my first term, this will be term, and this will be number. My first term's at 13. Oh, we gotta change this because it's negative. One, 2, 3, 4, 5. So these are terms. Yep. 3. Actually, I'm going to count by 5s. Negative 5, negative 10, negative 15, negative 20, negative 25, negative 30. Let's see if all this fits. So my first term is at 3. My second term is at negative 10. My third term is at negative 23. My fourth term is at negative 36. My other one runs off the graph, but you can see that they form a nice straight line, just like they could. So now the last problem says, which term in the sequence is negative 114? So we're going backwards now. I'm telling you that I want this to equal negative 114. You need to tell me what term this is. So we're looking for n. Solve for n. So we're going to use the formula. Our first term is still 3. We don't know the n, but we know our common difference is negative 13. And then we got to do some algebra. So I'm going to subtract 3 from both sides. Negative 117 equals this stuff. Now you can do a couple things here. You could divide both sides by 13, or you could distribute. I'm going to divide both sides by negative 13. Just going to make things a little easier. So 117 divided by 13 is 9, and that equals n minus 1. And then all I got to do is add 1 to both sides, so n equals 10. That means that the 10th term in this sequence is negative 114. So let's apply this to a story problem. The chart shows the length of Martin's long jump, so we need to write a function and then graph it. So we have our function. If you know you're going to forget this, write it down every single time. It'll help stick in your head. Now let's fill stuff in. My first term is 1. Or my first term is 8, sorry. And my common difference here, what I'm going up by every time, is 1.5. Now because we need to graph this, it's going to make a little more sense to either use the points on the table or convert this. We can turn this into a prettier function if we distribute. So distribute the 1.5 to both things in there, and then we can combine like terms. If you do 8 minus 1.5, you get 6.5. So now we can either graph that, making a table, or we can just plot these points. My first jump, I go over 1, 2, 3, 4, 5, 6, 7, 8. My second one is up 8, 9.5, and then 11, and then 12.5. And we can see we have this nice straight line here that graphs this function. So you should be able to do these 3 problems. Make sure you write down any questions you have, and we can go over them in class. Enjoy your night.